Hi everyone, I'm Federico Girella and I'm here to present our work titled Lots of Fashion, Multi-Conditioning for Image Generation via Sketch Text Pairing. Our work focuses on the fashion domain and in particular on the creative process of outfit design. During this process, artists make use of sketches of the items that compose the outfit in order to guide their creativity. Additionally, these sketches are accompanied by textual notes providing attributes that further describe the items. Our goal is to provide designers with a tool that can use both modalities to generate images of the final outfits. Some methodologies already exist to tackle similar problems. However, despite the impressive image quality, they suffer from a common issue. When paying close attention to the generated image, the model is wearing a striped blazer and a plaid shirt, despite the user requesting a plain blazer and a floral shirt. We refer to the problem of attributes appearing in the wrong items as attribute confusion, and we aim to solve this with our work. Our idea revolves around shifting from a set of global representations to a set of paired localized ones for each item in the outfit. Shifting to localized representations allows the user to specify the exact number and location of the item composing the outfit, as well as providing an explicit link between the partial descriptions and the item locations in the sketch. Furthermore, this linked information is available from the start of the outfit design process, making data collection easier and the final pipeline intuitive for the end user. With this idea in mind, we present LOTS, our localized text sketch adapter. LOTS works with both global and localized conditioning, as well as allowing for a flexible number of items for composing the outfit. LOTS works in two phases. In a first phase, frozen image and text encoders are used to encode each modality. As shown, the localized sketch and descriptions are fed to the respective encoders, and the resulting features are concatenated in a paired feature set. When multiple items compose the outfit, each pair is independently encoded. This is done to avoid information leakage between pairs and is our first step towards reducing attribute confusion. After this first encoding, we aim to compress the features in a shared representation space. We do so with our Pair-Former, an attention-based module for information fusion and compression. In the Pair-Former, the paired features go through a self-attention pooling process resulting in pair-centric features residing in a smaller shared representation space. Again, each feature pair is independently encoded to avoid information leakage between pairs. In the second phase, we aim to inject this information in a generative model for conditioning and set ourselves two goals. We want to maintain the flexibility in the number of conditioning pairs, as it is crucial in the outfit design process, and most importantly, we want to avoid merging the pairs into a single representation, thus reducing attribute confusion. We achieve this through a process that we call deferred fusion. Deferred fusion works as follows. First, the pair-centric features are concatenated into a single variable length sequence. Then, we augment a frozen text-to-image diffusion model with learnable cross-attention layers, as you can see on the bottom. Thanks to the nature of the attention mechanism, we are able to inject the concatenated pairs without any assumptions on their sequence length, thus achieving the flexibility goal we set. Most importantly, we avoid directly merging the pairs, instead deferring their fusion throughout the entire denoising process. This way, the attention layers can dynamically inject the paired information at each diffusion step. Finally, using the global text conditioning of the pre-trained model for style guidance together with our localized conditioning, we are able to generate the final outfit image with the attributes correctly localized, such as the plain blazer, the striped pants, and the floral shirt. To train and evaluate LOTS, we present our Sketchy dataset, the first fashion dataset with multiple local sketches and descriptions per image. We build Sketchy starting from the popular Fashionpedia dataset, published in ICCV25. We augment the Fashionpedia notations with pairs of localized sketches and natural language descriptions. The dataset is available to the public and can be reached on our project page on the QR code. We evaluate both zero-shot and fine-tune approaches on Sketchy and see that LOTS achieves the best overall results across metrics. We evaluate the impact of LOTS on attribute confusion with a specialized user study. In this study, we ask users recall and precision questions, investigating attributes appearing in the correct and incorrect locations respectively. LOTS achieves the best attribute localizations, surpassing all prior methodology. More comparisons are available in the main paper. Finally, we also release an interactive platform where you can test both LOTS and your designer skills. The user can draw as many localized sketches to compose their outfit, and the information is then fed to LOTS to generate the final image. Thank you for your attention. We hope you enjoyed our work and look forward to meeting you at ICCV.